When we study geometry, we are used to dealing with things like points or lines or areas, and we do this all on paper. Now, the question arises, is it possible for me to specify the location of a point using just numbers? Or perhaps if we talk about a line, is it possible for me to specify its position, its angle, its length, all using just a system of numbers? Can I talk about a shape, its area, its position, all using numbers? Well, that is the concern of something called coordinate geometry. Let's look at how we use it and why it might be useful to us. Many of us have played games, video games on our phones and our laptops, like for example, the FIFA football game shown over here. Have you ever thought, how does your computer keep track of all the players? How does it keep track of the ball and its movements? When somebody kicks the ball, how does it calculate where the ball is to land? How does the computer calculate the goal post and decide when it's a goal, when it's not? And how does it calculate the field lines to decide when the ball has gone outside? If you use maps to navigate on your phone, you would have realized that very often you can find your location on a map. How does your phone use satellites to track your location? At the same time, from your location, how does it, if you search for hotels, how does it calculate which hotels are close by? And when you ask for directions, how does it calculate the distance to a particular hotel? All of this is done using coordinate geometry. So let's get down to actually finding out what it is. To do this, I'm going to use the help of two of my friends. One is called Frankie Mouse, the bigger one, and the other is called Benji, the smaller one. So Frankie Mouse has been inside a house, and Frankie Mouse, when he went inside the house, he found a rasgulla and he also found a rasmalai. And both of these were present along a wall. So now, how does he tell Frankie Mouse, how does he tell Benji Mouse where to find these, especially considering Benji Mouse has never been there? So he can begin by specifying the entry point in the wall. This is the hole through which the rats come, and he might choose to call this entry point 0. If he is a mathematical mouse, he might choose to think of this as a number line and say that the rasmalai is 4 units or 4 meters to the right, and he might choose to say that the rasgulla is 6 meters, or perhaps call it -6, using it as a number line from the point of entry, -6 meters. Well, this is relatively simple. Unfortunately, life isn't that simple. Normally, you will find a rasgulla and rasmalai are not kept near a wall. You might find them on a table, and to make matters worse, you might have a third object like a piece of cake. Since all three are not in a straight line, you need a slightly more complex system to describe their positions. To do this, Frankie uses a table mat, a green colored table mat, as his reference point. From the center, he makes 2 number lines or 2 axes, one in the vertical direction and one in the horizontal direction. Let's look at the rasmalai. So Frankie might say that this rasmalai is in fact a total distance of 4 units horizontally and 1 unit vertically. So let's call this 4, 1. Now to describe the position of the cake, the position is 4 units from the center, but since it's to the left and these are mathematical mice, he might choose to call this -4. And vertically, let's say it's at 1, 2, 3 units from the center of the table mat, so it is -4, 3. Now how about the Rasgulla? So the Rasgulla comes to about, let's say, minus 7 units in the horizontal direction. And now because it is below the center or south of the center, we have to use negative values on this side. So negative 1, 2, 3, 4, 5, 6. So let's say minus 7 in the horizontal direction, comma, minus 6 in the vertical direction. So using this, Frankie has successfully told Benji how to locate his food on a surface, on a plane. So therefore, if we use a single number line, we are able to specify location in one dimension. That means location in a single line. If we use two axes, we find that we are able to specify location and other properties in two dimensions or a surface or a plane. What happens if we throw in another axis? Well, you get 3 dimensions, and in 3 dimensions we can talk about the surface. If you see from X and Y, they form a flat surface, and Z will tell us about the distance above and below. So when we use 3 axes, we are able to describe something in 3 dimensions. This is the term 3D you may have heard of, 3 dimensions, and therefore in actual space we would use 3 axes.